Hello everybody, I'm Yannick Leroy, head of the Maritime Spatial Planning Unit of the French Hydrographic and Oceanographic Service, the CHOM, with the French acronym. With my colleague Adeline Souf, also from this French public body, we will present you this communication, challenges for digital MSP, case of interoperability/harmonization process. This communication is structured over 5 points. So to start, for governing seas and oceans, Poseidon, god of this complex environment, here in its non-checking version for the audience, must make decisions, must arbitrate between several possible strategic ways to guide us, the mortals. So for us, mortals, governing by maritime spatial planning, meaning redefine the sea space-time through a rational methodology of CU's function. It's only possible by following a robust knowledge building process. Meaning, to be metaphoric, guiding the space by knowledge, build an information for structuring the grid, and mainly geographic, and data, based on data, for mining the structure. This informational system is performed by the digital turn observed in MSP context since now around 12-15 years, with the growing role of geoportals. Geoportals are web portals providing access to search and display products and services for geographical geolocalized data. Of course, it exists different types of geoportals, to simple data portal, to knowledge platform with, for example, decision support tools directly integrated. For this communication, we get the example of the Dutch MSP plans because, if I may, it's a good student, a really good example. And this digital turn is a big shift because we are moving from numerical national MSP plans, for example, through generic PDF documents or GIS map extracts, to a digital national MSP plans incorporating analysis tools and new resolution technologies. So geoportals are not only the support of the governance, but now it's the mode of governance itself. So it's a big move. This relatively new situation for MSP is not surprising if you compare with urban planning history, for example, but leads us, MSP experts, to ask ourselves new questions. How speaking the same data language? How connecting with other national MSP plans? Especially when we think in Europe at an European sea basin level with a translational policy as the European Green Deal objectives and the target to decarbonize the European economy through notably a network of marine renewable energy projects. So new questions, new issues or challenges, and new semantics. In this new digital world, there is a need for clarity, not only to highlight semantic nuances, but to understand deeply what are the challenges about data, information, knowledge to support decision, etc. So for us, CHOM, we use the data, information, knowledge, wisdom pyramid to tackle these challenges. Data as a foundation are facts, signals, or symbols that have no meaning outside the human mind. Information, mainly geographic in MSP context, emerges through cognitive processing data, arranged and ordered in a consistent way. Knowledge constitutes a collection of information with its associated context, of course, giving a specific human understanding. And to reach the top of the pyramid, wisdom, a fair and shared understanding to make decisions. The DKW pyramid has been developed by a professor in information science, Russell Ackoff, in 1989 in the review of the urban planning in US. But for us, it's an approach to tackle the challenges for the digital turn of MSP as a practical and technical device, notably here about interoperability / harmonization of data. So for us, it's not a hierarchical logical system, but a way to understand and to try to tackle this challenge. And we use it directly into the new European MSP project, the Northern European Sea Basin project. The NSB project supports the GNSBI, Greater North Sea Basin Initiative, a particular initiative which aims to strengthen the political coordination for MSP in the North Sea and fostering international cooperation for MSP in this extended point of view of the North Sea, with a close ties to the Baltic Sea. This is the geographic scope of the GNSBI, and it's why I mentioned the extended point of view of the North Sea, because it includes English Channel, Celtic Seas, and the south of the Norwegian Sea. So in the NSB project, we will assess this challenge, if I may, for the mosaic of national MSP plans, some of them available on MNet, the European MSP geoportal. Others soon are to be considered as they are outside the UE. For example, the national MSP plan from Norway or from UK. In this geographic context, we are focusing on maritime safety as a key dimension to highlight the challenges of this digital turn about interoperability / harmonization. Maritime safety entails the risk awareness of navigation conditions in a given physical and human environment. It's about people, it's about goods, it's about environment at sea. So maritime safety is not surveillance, it's not maritime security. It's very important to distinguish, to make the difference between this notion. Maritime safety is about risk. And it's clearly identified in the European Maritime Spatial Planning Directive, through especially the Article 6b. But why maritime safety useful in our case? Because this cross-cutting nature across all maritime sectors. Maritime safety helps for informing and current and future deployment / development potentiality according navigation conditions. Two elements to consider. The factors affecting maritime safety can be grouped into internal and external factors. First point. Second point, in MSP context, we focus, of course, on external factors, including, amongst others, ice and water levels, maritime traffic safety zone, water conditions, operational and planned human activities as marine renewable energy projects, maritime traffic intensity, etc., etc. If we try to understand it under our informational system, with the excellent, again, infography of the Dutch government, knowledge is the risk awareness of maritime safety for the area concerned. Build an information with heat risk maps, which geolocalize the most risky zone based on the data crossing several data clusters. For this, for us, a lighthouse in the night for interoperability / harmonization We use a very useful work provided by the technical expert group on data for MSP with the Maritime Spatial Planning Data Framework. This document presents the conceptual framework proposed to be applied to identify and structure the data necessary for the development of maritime spatial plans. The MSP data framework provides the structure to organize input spatial data that needs to be considered within the full MSP process. The MSPDF highlights 7 data clusters are fundamental to implement, assess, or monitor MSP plans or specific sectors if you want. Each data cluster is structured by a first level of categorization linked with existing guideline source as INSPIRE, the Geographical Information Infrastructure European Directive. For example, about the data cluster 5 named Operative Maritime Activities and Planning, the MSPDF uses the European INSPIRE structure with primary, secondary, tertiary production, and transport network logistics and utilities. For example, fisheries and aquaculture activities are under the umbrella of primary production. Marine renewable energy projects are under the umbrella of the secondary production, etc. Previously mentioned as a checklist, the extended ILUX code of resulting of the INSPIRE value system list is a digital resource that provides the possibility to map maritime activities with necessary levels of details. So for us, as you can guess, maritime safety is not a cluster in itself or a category in itself, but it's an octopus category, if I may, crossing several data clusters. Still about the data cluster 5 and operative maritime activities and planning, in following the MSPDF guidelines for addressing the interoperability / harmonization of data to feed the national MSP plans, we have detailed it with a fine categorization architecture of 5 subcategories. If you focus on the secondary production, renewable production, energy, we need potentially to use all these datasets highlighted in yellow, if they exist, of course. In this framework, we inform the datasets with the extended ILUX value based on INSPIRE land use model for working into land sea interaction perspective. This share and common value is the vector to making able the interoperability of indigenous datasets for integrated it in sea-basin perspective for digital MSP point of view. So as you can see there, there's a common EILUX value between different maritime renewable energy activities. So certainly we must need to go depth to detail the EILUX value. Another point is about the availability on MNet of the main category of the marine renewable activities and the third rank of the categorization architecture. If you put our case on the table, meaning on the sea basin level of the Greater North Sea, it's easy to identify the challenges in concrete terms. I mean digitally through the European MSP geoportal MNet. For example, still with the example of the Dutch MSP plan, here we have targeted 2 offshore wind farm projects into the Dutch waters for now with construction status. As you can check, there is no attributes in metadata about the possible EILUX value which exists to inform these activities. But According that, the Dutch MSP plan and EMANET integrate for this area the iLux value for the zone covering this offshore wind farm project in construction as the information of the CU's function, which is good practice, of course, as a proof of a potential interoperability / harmonization for maritime safety risk analysis, for example. So, in terms of next steps, to go further, first of all, we think it's fundamental to make the difference between input data and output data. How we see. Input data is the reference data which feed the MSP plans. Output data is the zoning area per CU's function according to the methodology of country. It's the case of Netherlands, it's not the case for France, for example. And for that, take the example of base maps, an essential geoportal if you want to take this digital turn properly. Second, next steps, specify precisely the iLux value. The work provided by the EU PGC and Andre's team is fundamental, but I think we think it's possible to go further to detail all the stage, for example, of a marine renewable energy project with the test sites, the construction status, the production status, etc., etc. Of course, in the perspective to produce or to provide a robust maritime safety risk analysis. The third next step could, of course, could be to use the MSPDF categorization through the 7 data clusters. It will help to make clearer and transparent the interoperability / harmonization process, in addition with the refining work of SHUM. It could be used, for example, in EMANET. And the last, but not the least, first, European use EMANET data model to improve the digital turn of MSP process. If it's essential for improving the outlook of marine biodiversity, notably through this recent scientific paper, for example, it's also the case for MSP. So thanks for listening. If you have any question, don't hesitate to contact us, me, Yannick, or Adeline, my colleague. So I wish you a good day. Bye-bye.